Hi, I'm budding researchers, and we are back again. And our main focus for this episode is the demonstration of one-way analysis of variance using the SPSS. So this is our case study. Now, we need to go say goodbye to our flying EP's case study. And we would like to highlight now the female athletes of the senior high school. So ASHS female athletes. The co-educational system of ASHS has led to the promotion and engagement of female athletes in different sporting events such as UAAP. The University Athletics Office conducted a study on the daily energy intake of 4 groups of female athletes. So you have the control group, the fencing group, football group, and basketball group. They estimated their daily energy intake using a quantitative food frequency questionnaire. Now, the main question here is there a significant difference on the daily energy intake of the 4 female athletic groups? So we need to prove using statistical analysis. So how do we go about considering the case scenario? So let's establish first our hypothesis. So we can say that for the null hypothesis, there's no significant difference on the daily energy intake of the 4 female athletic groups. And the alternative hypothesis here, there is a significant difference on the daily energy intake of the 4 female athletic groups. So for the SPSS drills, so you can download the files here and then you open your SPSS software and make sure that you input also your data based on what is available on the Excel file. Once you have accessed the file, the Excel file, so kindly check. So this is the content. So you have here 4 groups. Take note of the legend. So 1 represents the control group, 2 represents the fencing athletes, 3 football, and then number 4 you have basketball. So you have the groups here on the first column, and then you have the energy intake in kilocalories on the second column. So we will copy this data on our SPSS sheet. So opening now this file. Actually, I already inputted the details, but I'd like to highlight the process, how you can fill up the table. So first one, since this is a one-way ANOVA, so there's another process that we need to look into so that you will not be confused later on how you will analyze the data. So you have here first, you have group variable. So you have here, it's numeric, but we need to establish the values. So remember that we have 4 groups. So how do we fill up this column? So kindly click this part. You have that portion having 3 dots. And although I have inputted all the necessary groups, so let me just remove one so that you will know how to input the values here. So take note that group 1 represents, so type here the value 1, that's the control group. So you just type control. So once you're done inputting all the necessary details, then you can click add. So you have now the completed value labels. So 2 for fencing, 3 for football, and then 4 basketball. So you just click OK. Then take note that the group variable here is considered as a nominal measure. So we represented the groups into numbers 1, 2, 3, 4. Then you have the energy intake. So here, so decimals should be in 0, and then it's a scale value because we have used survey forms to measure the energy intake of the athletes. So going now to the data view, so simply just copy from the Excel file and then you paste it here. So you have group and then the energy intake. So how do we explore one-way ANOVA? But remember our rule, and in the assumptions of applying ANOVA, we need to check the normality of data first. So how do we explore the normality of data? So first, you click Analyze, then Descriptive Statistics, then you have Explore. Then input now energy intake on the dependent list. So the group data, since it's just nominal, so we don't need to explore that. So you have statistics, you have 95%, so we can click continue plots, you can click histogram and then normality plots with test, then continue, and then you click OK. So we'll wait now for the generated analysis. So you have 42 number of participants here, and you have the mean score of the energy intake, and you have the test of normality. Since we only have 42, so we will focus on the Shapiro-Wilk test. And as we can see, it's greater than 0.05, so we can assume that the data is normally distributed. As simple as that. So the histogram also would verify that, and even in the normality plots. So you can see here, lying on the best fit line. Okay, this time, let's try to apply the one-way analysis, one-way ANOVA to explore the data that we were able to gather from the given scenario. So just click Analyze, then you click Compare Means, then you click One-Way ANOVA, and you now place the necessary variables on the specific cells here. So for the group data, place it on factor box, and then the energy intake, that's on the dependent list. So we need to click also the necessary inputs, details for ANOVA. So for contrast, just leave it as is. So I'll close this one. Post hoc, this is essential later on when we try to look at the normality, the distribution, the variances that we have for our data. So if equal variances assumed, what I usually use is the Tukey post hoc. Others would click Bonferroni, but they have the same function, so it's easier to just consider one, and that's Tukey. And for equal variances not assumed, what I usually use is the Games-Howell. So at least I have clicked Tukey, and then I have clicked also Games-Howell, and continue. Then options. So, well, you can click on the descriptives if you would like. Then that's it. So there. So what I will do now, I'll click OK, and there. So you have here the descriptives. You need to consider the descriptives here for your interpretation later on. So you have the number of athletes per group. Control, you have 11, fencing 7, football, and many others. You have also the mean score of the energy intake, and you have the minimum and then maximum scores. And you have here the ANOVA. So you have now the F ratio. You remember our discussion earlier. So you have here the significance value of 0.026. And you have here the following values for post hoc test, Tukey, and then Games-Howell. And you have the homogeneous subsets. So this is just one way to verify the results of the post hoc test. So how do we interpret the data now? So focusing on the interpretation.